This week on LCARA Ham Radio, we get out the service monitor to see if we can figure out why we're getting interference on the Monticello repeater. There's been a bad hum, and we've also had some interference from something. That's what's coming up this week on LCARA Ham Radio.
All right, gentlemen, what we've done is we're building something called what we call an ISO-T. It's a RF sampler, really. And so we took this connector apart. This little thing unscrews out, and Don cut this end of it off here. And we're going to put another connector in there, and that's going to give us an air gap in our connection, and we'll have about 40 to 60 dB of isolation between either one of these ports and this one up here. This will allow us to make insertion loss, sight noise measurements and stuff on the receiver while the transmitter is keyed without blowing up test equipment. This is an old school way of doing it. They make commercial units, they're about $300, but we're going to do it on the cheap. And this is
as every good club wants.
Over the year. Yeah, the cheap is the king. So the next stage is we take one of these guys right here and we thread this in there, and we get some pliers and we tighten that down, and now we put our adapter here for our input goes to the test equipment, repeater, antenna, or duplexer antenna, and then we're set. And so whatever adapters we need, we have them. If we need to go UHF to N, you know, we've got adapters, we can do that. So this is now a bona fide piece of test equipment, and what we'll do is we'll tighten that down, and when you get back to the shop, if you just dimple the end with a punch so it can't be taken loose, and we'll measure it at different frequencies to see what the insertion loss is at 6 meters, 2 meters, and UHF. That loss will be different depending on what the band is. So what may be 30 dB at one band could be 40 dB at another, and that's just the nature of the beast. So we'll move on to the next stage.
So Ron, explain what we're doing. Why are we building that?
What we're doing is the site has some kind of noise on the receiver. We don't believe the receiver is bad. What we think is just RF desensitizing the receiver front end, and we got to find out why. Is it our duplexer alignment went out? Is there something environmental? When I mean by environmental, I don't mean the trees. I mean radio-wise. If somebody put something on another tower that didn't used to be there, that changed the RF environment. We don't know what we're dealing with, so this tool will help us identify which direction to look.
Got it. You need a couple pairs of pliers? You have another set of pliers in there?
Right here.
Oh, he found it.
Yeah, there's another set in there of pliers.
Hi there. Okay, this is a 6 dB pad, 50 ohms in and out. This port is high impedance, not 50 ohms. This cable from the service monitor, this is a 50 ohm port. This needs to see 50 ohm in order to get an accurate reading. So we take a 50 ohm 6 dB pad and we put it on there. And now what we've got is we've isolated this port here, high impedance. It can go unterminated. The service monitor doesn't care. This isolates the service monitor from the high impedance point of this key. And that's what that is. That's what we do. All right, so what's our input? 144.550?
550. 144.550.
Alright, well, where's the receive port? Right here? This is the receive port. So what we want to do is we want to measure the receiver sensitivity first.
Can you do both at the same time?
Well, we're going to do this.
We'll inject a signal in there.
Oh, I see. I just heard it click.
He's breaking squelch at -124. That's a hot receiver.
Yeah.
When we get up to 118, 119, that's about 12 dB quieting.
Full quieting.
Yes, it's not full quieting.
It's still squishy.
Not get a little shake.
Yeah, that's about 12 dB. So let's claim that 119 is our 12 dB quieting point. So without a cyanide meter,
You need a piece of paper or something?
yeah, let's just write it down.
This is why we have Don.
Got a crayon handy?
Yeah, just as soon as I get my crayon out.
He's getting his horse pencil out. His horse leg pencil, that big fat thing. Oh no, that's a nice pen. It's a nice little one.
Okay, now the next test we're going to do we're going to hook the receiver back up to the duplexer. Next thing we're going to do is we're going to find out what the insertion loss is.
Go ahead.
That's a 50 ohm termination right here. We're going to put that on top of this, so I need to get an adapter that goes into and goes out to.
Like that one right there?
No, that's an in. I need a,
Oh, you need a male BNC?
yeah. Okay, so now we get over here and we start well, we got descents.
We're desensing ourselves. So this is what we thought was happening. The duplexers aren't blocking completely.
All right. we need it.
So that's the termination dummy load to separate the output of the repeater.
All right, is the portable still turned on? Yeah.
Getting warm, Don?
All right, we need to measure this differently. Let's calibrating what the insertion loss of this T is. All right, so we may have cut a little bit too much of that pin off.
Well, we have another one of them. We have another one of them keys in there.
Yeah, we do, but what we're doing,
Are you just
see what the problem is see how we're loose? This barrel
not one bit?
has too much in-play in it. You know, there's too much metal in this barrel. So what I think we need to do, Don, is file this little probe a little flatter.
A little more file.
Yeah, we need to file it a little more because it's just enough to where it's getting touching the metal. So what we're doing is we're calibrating that RF sampler
We're
and
increasing the spacing just a little
That's
bit.
why.
yes,
Why are we increasing the spacing? What
we want to have.
More attenuation.
I want to have it set up to where we break squelch at -124, and I want it to break squelch at -84 through the device. That's what I'm looking for. That's what 60 dB, right? Yeah. That's what we want.
So currently it breaks squelch at 124, you said?
Yes.
And we're trying to get this filed so there's enough of a gap so that it takes minus
84 to break squelch.
84 to break squelch. So we
That's
want it
that's
to be
20
stable.
20 dB.
No, 60 dB.
60 dB, not 20, 60 dB. Yeah.
As you can see, I brought this because I've done this before out in the field.
Yeah.
But 84 to 124? Describe.
Okay, now we off camera, we had to recalibrate this. We had to file that pin that we cut in a little more so we would have our, we got 40 dB of isolation there. And so we had to trim it up so we can make our measurement.
All right. Okay.
All right, so what we're going to do now is we're recalibrating the service monitor. It
Okay.
had a warning, and we can't sweep this duplexer with it not being self-calibrated. So we're going to go through that. That'll take about 5 minutes for that to happen.
These are the cables here. This goes all the way up to the other side.
Oh, requires a 50 ohm load. Just finished the calibration. You pan down here, it
I got a lot of
calibrated the input, the output modulation, spectrum analyzer, which is what we needed to have it calibrate the spectrum analyzer. That way we can use the tracking generator. So now we're going to return back to that.
And now
We're going to go to standard. And we're going to go to track generator.
right?
Mod scope disabled and tracking generator. So now we need to come down here. And go tracking generator. And now what we'll do is we'll take
All the cables,
our receive port,
which that cable
and there we're
is hooked up
hooked up to the
from
input.
nothing yet.
And then this is the output. our generator port. I like to see the level much higher than that. Which means my fuse in my repair might be blown.
Here we got, lowest we can go is 2K.
Alright, how come I don't have any?
Okay,
200. There we go. Nope, that fuse is good.
That is okay.
So I guess minus 40 is our signal. I like to have more than that. Okay. So this is our pass.
That's your C there. That's your low side.
Thanks.
All right, now let's set our so our notch is way off.
Okay, go ahead.
We only have a 20 dB notch.
And it should be 80 or something.
All right, that's as low as my equipment goes. Well, wait a minute.
You can see that noise floor come up.
So we've only got 20 dB
So rejection.
by this equipment. So let's go to generator mode. Now, I don't have the dynamic range, so we're going to go ahead and pull the pads out for a test. I really should have brought the IFR monitor because it's got a different kind of a tracking generator in it.
What's a brand new spectrum analyzer in on?
In the truck?
No, we need to learn how to use it. Don't we?
Yeah, see, we're not getting our full. We should see 0 dBm out. Let me go over here. that's minus 50. It should change our scale. So let's start by, once you crack the nuts loose, let's see if we can, I'm going to try tuning up the pass.
You want both of them loose? You want both loose?
Yeah, both of these. See, here's our center line, our pass. Alright, now let's see what it looks like differently when we put the pads back in. See if the hump changes. And it didn't change much. Okay, let's lock these down.
So while he's doing that, Ron, give us an explanation of exactly what just happened.
We changed the pass tuning on the transmit port. So we were down about 3 or 4 dB, and that 3 or 4 dB, well 3 dB is half our power. So now what we want to do...
So the passport does what? It allows only what's there through?
This only allows the transmit. Well, this is the receive pass. It only allows the receive signal through. Let's
so 145,
again.
144.550, and that's the only. And so I see it here on the screen, Ron. This bump.
I need another BNC to. No, I need to put a 50-ohm load on that other port. I need to terminate the port. Maybe I got it over here.
Ron, describe here
what
we're looking at.
This is our receive pass. The center line of the gradicle is the receive center line. We want the hump to be maximum on that.
Okay.
This down here is our notch.
Yep.
And each one of these lines are 100 kilohertz.
Okay.
So
to the left is below 144.55.
Yes.
To the right is above it.
Right.
So we're trying to basically completely blank out what's our transmit frequency from the...
Right.
Ron put a 50 ohm termination load on the high frequency input.
All right.
Okay.
All we're doing is we're tuning that for maximum height on the bump.
Maximum power right on that center line. I'm going to zoom in on it just a little bit so we can all see this.
Now the other thing we can do too is we can loosen these screws and adjust the coupling to raise the, but I don't want to mess with that. So it looks like I've got only 30 dB of isolation on this can, and it's not right, but we'll have to make another trip with the other service monitor.
Well, like I said, I've got another set of those house that we retuned.
Alright, so what we did is we measured the receiver sensitivity without the antenna hooked up through this ISO T, and we had, with insertion losses and everything, minus 77 dBm signal to break receiver squelch. When we plug it back in with the antenna on it versus the 50 ohm low end on the transmitter, it now takes minus 65.3. So that's 12.3 dB of loss in sensitivity.
Why is it lost?
It makes the receiver less sensitive. So handhelds will be noisy getting in.
Well, and there you have it for now. Anyway, N4RLS knows that we have an issue with the duplexers. And it could be, a lightning strike, age. You just never know sometimes. This equipment has been in the shack for many, many years, and it was inherited from another club. But I will let you in that on an impromptu workday, which we will show in a future video, Ron took a different set of duplexers and got them completely tuned for Monticello. So we're going to be swapping out these duplexers that we currently have at the repeater site with a freshly tuned set of cans, and that'll be coming up in the future. Can't thank N4RLS Ron enough for his expertise with the service monitor and the ability to try to troubleshoot why we're getting interference on this particular repeater. Folks, if you don't have a Ron in your club, reach out to other clubs and see if they can help you with any issues you might be having. Many, many clubs would love to help you out. For the Lake Cumberland Amateur Radio Association, I'm KY4 BDP Brian. Like, subscribe, and we'll see you on the other side. 73.